Okay, so today is gonna be a very small session. Small, I don't know if small is the right word. Yeah, I'll stay here for only 3 to 2 hours now, today. Let me see what time is it now. Maybe 3 hours. Okay, so let's start. Functional programming, limitations and side effects using functional programming. If you haven't already figured it out, the issue in the previous challenge was with the splice call in the type close function. Fortunately, splice changes the original array is called on, so the second call to it used a modified array and gave unexpected results. This is a small example of a much larger pattern. Call a function on a variable, array, or an object, and the function changes the variable or something in the object. Hold on, let me change the name of the string. I always forgot to do this. And 50. I think now it's changed. Alright. This is a small example of a much larger pattern. You call a function on a variable, array, or an object, and the function changes the variable or something in the object. You call a function on a variable, array, or an object, and the function changes the variable or something in the object. One of the core principles of functional programming is to not change things. Changes lead to bugs. It's easier to prevent bugs knowing that your functions don't change anything, including the function arguments or any global variable. The previous example didn't have any complicated operations, but the splice method changed the original array and resulted in a bug. Recall that in functional programming, changing or altering things is called mutation, and the outcome is called a side effect. A function ideally should be a pure function, meaning that it does not cause any side effects. Let's try to master this discipline and not alter any variable or object in our code. Fill in the code for the function incrementer, so it returns the value of the global variable fixed value increased by 1. Okay. Name is changed. The last challenge was a step closer to functional programming principles, but there is still something missing. We didn't alter the global variable value, but the function incrementer would not work with the global variable fixed value being there. We didn't alter the global variable value, but the function incrementer would not work without the global variable fixed value being there. Another principle of functional programming is to always declare your dependencies explicitly. This means if a function depends on a variable or object being present, then pass that variable or object directly into the function as an argument. So here probably. To always declare your dependencies explicitly. This means if a function depends on the variable or object being present, then pass the variable or object directly into the function. There are several good consequences from this principle. The function is easier to test, you know exactly what inputs it takes, and it won't depend on anything else in your program. This can give you more confidence when you alter, remove, or add new code. You will know what you can or cannot change, and you can see where the potential traps are. Finally, the function would always produce the same output for the same set of inputs, no matter what part of the code executes. Let's update incrementer function to clearly declare its dependencies. Write the incrementer function so it takes an argument and then returns a result after increasing the value by 1. So far we have seen two distinct principles from functional programming. Don't alter a variable or object, create new variables and objects and return them if they need be from a function. Hint. Using something like var new r equals rvar, or rvar is an array, we simply create a reference to the existing variable and another copy. So changing a value in new r would change the value in rvar. So when you create a new variable that is equal to a different array, when you change the variable, it changes the array also. Declare function parameters. Any computation inside a function depends only on the arguments passed through the function, and not on any global object or variable. But what if there is a lot of arguments? Well, let's see. Adding 1 to a number is not very exciting, but we can apply these principles when working with arrays or more complex objects. So this is the global variable, change the code below. This is true that I'm gonna change. Okay. Rewrite the code to the global array book list here is not changed inside either function. The add function should add the given book name to the end of the array passed to it and return a new array list. The remove function should remove the given book name from the array passed to it. Note, both functions should return an array, and any new parameter should be added before the book name parameter. So you can change the array. So the global array book list not changed inside either function. Variable equals book index equals book list dot index of book name. Book index plus equal to 0. Slice instead of splice. Probably the first change, but I should change both of them. Now the obvious thing that comes to mind, to create a new array, put the same values of the book list into the new array, and then change the name of the variable there. But that doesn't make too much sense to me. But maybe instead of book name, we put book list. Oh. So it takes the index of the name. If it doesn't exist, it's gonna be -1 and the code is not gonna run. If it does exist, it's gonna be bigger than 0. And then we're gonna splice the list by the index and 1. Return book list. Let me do this simple change and see what happens. But if I'm not supposed to change the variable, why are the functions explicitly made to change the variable? No enter a variable or object, create new variables and objects and return them if need be from a function. It's using something like var equals new, r equals r, var is an array. You simply create a reference to the existing variable and not a copy. To change a value in UR, would change the value in your var. Declare function parameters. Any computation inside a function depends only on the arguments passed to the function. And also on any global object or variable. So that's what I have to change, right? I don't understand this. The way that it's phrased is strange, because if I'm logging book list at the end, isn't that the purpose of the functions? To change the global variable specifically. Adding one to a number is not very exciting, but can apply these principles when working with arrays or more complex objects. Write the code so the global array book list is not changed inside either function. Add function should add the given book name to the end of the array, pass it through it, and return a new array list. But I can change the other array. Just no, know what to do. That way I push the entire array, at least not fine. I'll push the entire array to this new variable and return it. The add function should add giving book name to the end of the array, pass through it, and return a new array. The remove function should remove the given book name from the array passed through it. So this one is more complex. It creates a variable book index. That's just so maybe that's all I need to do here. But I don't understand why is logging block book list here. Let's try this. New book list should equal to the values are wrong. Maybe we should declare the variable outside of the function and push the list there. But it feels kind of like a hack because I'm doing basically the same thing. I was taking from book list. That's the only way I see how to do it. I can't see any other way. Now let's do this, and if it's not, I'm gonna see for look for this. It's not a question of not knowing what to do, it's a question of not understanding what they want. Exactly. Let's see if this, yeah. So I'm gonna go from the beginning here. If you're having trouble with changing book lists, try using a copy of the array in your functions. Passing by values versus reference. So this is when you pass a value. Isn't that with the temp thing that I learned another earlier challenge? Because the value is primitive and creates a new location mark, parts the into the address and fills it with the value 5. And create variable b and assign the value of a, the equals is operated in others we're dealing with a primitive value. 5 in this case, and creates a new location memory points b to the new others. Blah blah. So when we pass this value, a new value to a, b is all equal to 5 still. As discussed earlier, when we assign b equal to a new location in memory was created. The equals operator did not simply have b point to the same spot in memory that a does. B was given its own location filled with the value of a at the time 5. So when a was changed, it does not follow suit because it's pointing to its own spot in memory. Passing by reference relates to objects in JavaScript. All objects, including functions like before I'm going to utilize the picture below as a visual representation of what we'll be discussing. As you can see above, in a variable is set equal to an object. The equals operator identifies that the value is an object. There's a new location memory and points a to the address represented by a. We create a new variable b and assign the value of the variable a. The equals operator knows we're dealing with an object and points it same thing as before. Notice that no new location object in memory is created. Also, it's different because they are going to be linked together. When it's an object and when it's not an object, they have different spots in the memory. Same address, this is true, can lead to some interesting interactions. If we don't know how things work, let's take a look at the example below. I create a variable. Okay, but this doesn't change anything. I know that's the case, but it doesn't help because it says I can create a variable and make it equal to the array outside because it's going to point to the same place in memory. And I can't modify the array. So if I make it equal to another object or variable, is gonna change both. And I change the new variable. And if I do it like I did before, then every time the function is called, it's gonna add the book list, entire book list again. To the new array. Yeah, I don't understand this one. I think I'm just gonna see the answer. Because otherwise I'm just gonna be stuck. Something that is not very productive to be stuck on.
Hey everybody, welcome back. Today we're going to refactor global variables out of functions. So far we have seen two distinct principles of functional program. One, we don't alter a variable or object. We create new variables and objects and return them if need be for a function. We declare function arguments by computation inside a function depends only on the arguments. The computation inside of a function depends only on the arguments and not any global variable or object. Adding 1 to a number is not very exciting, but we can apply these principles when working with arrays or more complex objects. So we want to rewrite this code so that the global array book list is not changed inside either function. The add function should add the given book name to the end of an array. The remove function should remove the given book name from an array. Both functions should return an array, and any new parameters should be added before the book name parameter. Okay, so we've got a global variable here with a list of 1, 2, 3, 4 strings inside of the array. There's 4 strings, which I guess are titles of books. This function should add a book to the list and return the list. So here we're returning the book list, but what we want to do is have the book list here as well. So we could just say the book list, the book name, and then the book.
Book list push is not a function. You will return book list dot push book name.
List. We could call it maybe, I like to make it explicit, so original book list. Okay, so we want to say, instead of doing book list into here, we want to change this so that it's original book list.push book name, and then we want to return not the book list, but the original book list. Okay, cool. Now we're getting an error, but this is to be expected because now we don't have the original book list being passed in. So the function should remove a book from the list and return a list. Well, this one we want to add. So basically we're just taking the original book list, putting the new book on here, and then returning the original book list. And so therefore we're not altering. This function should remove, so here we want to remove, so we want to add code here. So we want to remove a book name, but we should also pass in the original book list. This is outside of the scope of the other function, so this will be fine to use the same variable name. So the book index is equal to book list.index of book name. So this finds out the position. So if the book name is on the electrodynamics of moving bodies, and the index of, and we ask on the book list, what is the index? And so that index would be 0, 1. This would render out to 1 here. If book index is greater than or equal to 0, which means if the if the book is there, if the book's not there, the result of this will be -1 because the book name will have an index of -1 because it's not on the book list. This is just saying if the book is in the original book list, then what we want to do is book list dot splice. Well, we could do that, but we could say original book list dot splice the book index and 1. So that means we're going to cut out 1, and the index here it would be equal to 1. So 1 and 1 would remove the first element. So on electrodynamics of moving bees would be removed, and now we want to pass back the original
because
book list.
An argument of
okay, cool. Now I'm going to slide this out just so it's a little bit easier for us to see. Original book list dot push is not a function. Okay, so here's what's happening. In the code down here, they're stating the add and remove. The original parameter is the book list, and the secondary parameter is the individual book. Now, in my code, I've switched to these because right now I've got book name coming in and then original book list. So this is switched. This is the original. This is the book list that we want to play with. So I'm going to remove that here and place it here. I'm going to do that up here as well. Original book list is not defined.
So it's just the order that's wrong. Let's see if this passes. It's still changing the thing. If I give it another name, it's not gonna have the same values of the book list. Maybe it's just a splice. Book list splice.
Add, remove. Okay, so original book list is undefined. The problem is the L. Original book list should be like that. Okay, so now that our code is running, let's see. Well, it takes add the book list, newer book list. We're going to remove on electrodynamics of moving bodies. And here, now where's the console log? Oh, I'm console logging the book list. Let's say new book list. So what's happened here? The new book list, we're going to add a brief history of time. So it should be a brief history of time has been added to the new book list. A brief history of time. It's actually added twice. That's kind of weird. Console log. Let's see. New book list. Is that? Yeah. Okay. So the new book list. We're going to add to the book list a brief history of time. So we're adding a brief history of time to the book list. That's weird. Let's run the test and see what happens. Okay. Cool. Nothing's passed. Now we want to add the original book list book name. Original book list dot push the book name. We return the original book list. Let's make it all book list like that. New book list is equal to book list. A brief history of time. So what's happening here is we're adding to the book list a brief history of time again. Should not change, and still, just book list should not change. So this one should not change, but for some reason a new book list is changing. So we're alternating the array somewhere in here. I think it's here, original book list. Okay, so maybe we console.log the original book list. And I'm just going to comment this out. So, okay, yeah, original book list. So what we're doing is we're adding to it here and we're adding to it here. The first time that we add to it, it's brief history of time. We want to add a brief history of time, and then we want to remove on electrodynamics of moving. That seems like it should be right to me. Newest book list. Let's get rid of this console log. The newest book list is undefined. That seems strange. What happens if we throw this guy in there? We have a brief history of time on there 3 times. Push. We want to pass in book list. And new book list should return. Okay, so instead of saying original book list like this, we need to clone it. So the new book list is equal to, a clone of the original book list. And our new book list is what we'll pass back. New book list is not defined. Oh, and we need to say let new book list equal there. And so console log the newest book list. Well, let's say the new book list. Let's see if that works first. Okay, this seems to be correct. So let's run the test and see if they click. Okay, so we've got this one. So the new book list, when we just add, it has a brief history of time. So that's the one that we just checked here. So the new word book list should equal here. So the new word book list, we've got the remove functioning properly, apparently. But no, I think we should still alter this one. Original book list. Well, we can't have it be like that. So we need to say, we're going to have to do this here too. So we're going to let the new book list equal ... the original book list. And then we're going to say the new book list is we're cutting out that element, and then we're going to pass in the book list that we have spliced out the element. And so now, if we run the test, I bet they'll pass. So yeah, I hope that helps. What was happening there?
Yeah, that doesn't make any sense to me, actually. The only thing that was missing was this ... book list. I don't understand why this is correct way. I have to do this. Now it should work, I think. I don't understand why this creates a copy, but the other way with the empty array doesn't create a copy. It does create a copy, actually. Like if you make a variable, then make it equal to book list, creates a copy. Doesn't create a copy, but when you do like this, it doesn't create a copy. Like, why is that the case? Okay. So far we have learned to choose pure functions to avoid side effects in the program. Also, we have seen the value in having a function only depend on its input arguments. This is only the beginning, as its name suggests functional programming is centered around a trio of functions. It would make sense to be able to pass them as arguments to other functions, and return a function from another function. Functions are considered first-class objects in JavaScript, which means they can be used like any other object. They can be saved in variables stored in an object or passed as a function as function arguments. Let's start with some simple array functions, which are methods on the array object prototype. In this exercise, we are looking at array.prototype.map, or more simply map. So, this giant variable, which is with a bunch of objects attached to it. Close below this line. So the name is watchlist of this variable. And it has a loop that pushes the rating title watchlist. Title watchlist. Okay. The map method iterates over each item in an array and returns a new array containing the results of calling the callback function on each element. It does this without mutating the original array. When a callback is used, it is passed three arguments. The first argument is the current element being processed, the second is the index of that element, and the third is the array upon which the map was called. Current element being processed. Watch list I, probably. And instead of this loop, it's gonna have an array on a map. Watch list dot map. Undefined is not a function. And we need to make it equal to a variable. I forgot to use how to use map. When the callback is used, it passes three arguments. The first argument is the current element being processed, the second is the index of that element, and the third is the array upon which the map method is called. See below for an example using the map method on the user's array to return a new array containing only the names of the users as elements. For simplicity, the example only uses the first argument of the callback. So it has the names there. For users, it should be watch list. The watchlist array holds object information on several movies. Use map on watchlist to assign a new array of objects with only title and rating keys to the ratings variable. Code in the editor currently uses a for loop to do this, so you should replace the loop functionality with your map expression. Yeah, that's what I was thinking. So I have to create a new function maybe. Yeah. Const. And define that function. Maybe it's because I haven't written the function, so. I want to get the movie, the title and the rating. Why is not defined? Let me just copy this. Maybe it's watchlist.title. Maybe I need to delete this. This is gonna be the element, right? And there's another one. Cannot read property title of undefined. Put a comment on this. Oh yeah, I need to assign to ratings also. Well, it's because this is not defined. So how do I iterate this to array? Maybe this is just rating instead of ratings. Maybe here is watch list and here is ratings. So, no. It creates a new array populated with the results of calling a provided function on every element in the calling array. Function that is called for every element of array. Time callback executes, the returned value is added to new array. Current value, and I'm processing the array. So how is this callback here? Ratings dot push. Maybe this is the callback. One is not a function. What is the current value? Maybe the index is just the title and rating. Might have to watch a video on this. Yeah.
Another very useful and powerful method we have in modern JavaScript is the map method. With this method, we can map each item in an array to something else. So following from the example in the last lecture, we have an array of positive numbers. Let's say we want to construct some HTML markup using the elements in this array. So we call filtered.map. And once again, we need to pass a callback function here. This function, just like the function that we passed to the filter method, can have three parameters: value, index, and array. So in this case, again, we're going to work only with the value. So we can pass a function or an arrow function. So we get a number, and then we want to map this to some HTML markup. So we can add a string in an opening list item element. Then we add the number, and finally the closing list item element. So with this markup, we can display each number using a bullet point. Of course, we need to put these inside of a UL element. And I'm going to show you that in a second. So let's see the result of the map method. I'm going to store the result in a constant called items. And now let's display this on the console. So you can see each number is now mapped to a string. That's our list item. So now we have an array of strings. We can use the join method that you learned about earlier to join the elements of this array and create a string. So constant HTML, we set it to items.join, and then display this on the console. Now instead of an array, we have a string. Note that by default, comma is used as the separator. We don't want to have comma in our HTML markup. We just want to combine these using an empty character, like this. Save the changes. Now comma is gone.
Push is not a function. Let me see something. Still not a function.
The only bit that is remaining is the UL
understand.
element. So a very simple implementation would be like this. We add UL, then concatenate it with all these items, and finally another UL. Save the changes. And here's our HTML markup to display all these numbers using bullet points. Now, later in the course, I will show you a more elegant way to implement the same thing. All I want you to take away from this lecture is that we can use the map method to map each element in an array into something else. Now, in this example, we're mapping these numbers to strings, but you can also map them to objects. Let me show you another example. So I'm going to delete this HTML. Let's expand this a little bit more. So instead of mapping a number to a string, let's say we want to map them to an object. So here I'm going to define an object. In this object, we want to have a value property, and we want to set that to this number. And finally, we want to return this object. Let's look at the result. Oops, I made a mistake. I deleted the HTML constant, and that's why we get this error. HTML is not defined. So let's display the items constant. Now here's the result of our map. We mapped each number to an object with a value property. Okay, it's very useful when building real-world applications. Now let me show you something tricky.
Map first and
In our
then
callback
push.
function, we are declaring this constant and then returning it. Technically, we don't need to declare this as a separate constant. We can simply put the return keyword here and return this object because we're not working with that constant, with that object constant, okay? So save the changes, we still get the same result. Now, earlier I told you that in your arrow function, if you have a single line of code and you're returning a value, you can exclude the return keyword as well as the curly braces. So let's do that and see what happens. So remove the return keyword and the
But this is not that. No, it is. And now I push. Now I think it goes. That's it. Okay. Initially equal title inception. So here it has title too. Now I think it goes. Still wrong. Waiting should equal title inception. Waiting any title interstellar. The Dark Knight 9. What's wrong with this? Was one brackets off. Here it has two brackets, here it only has one. Maybe I should put const ratings equals this. Or ratings equals this. Instead of pushing. Let's try. I wonder why he creates the variable here. If he's telling to assign to a new different name. Let's see the hints and the video from the guy. So I think I understand a little bit better now. The map only maps the values inside of this variable, which is a sets of objects. So it maps it maps everything, and then you don't need to push because it's already filtered, let's say, for the specific ones you specified here, you declared here. It's basically the same command, but it doesn't change when you push, it changes the main array. When you use map, it doesn't change the main array. And I guess it was confusing to me because I never saw this push here before. The stuff inside of this push. Written like this. Title. Watch this title.
Precisa aceitar cartão de crédito e boleto na sua loja online? Cadastre-se no Pagame.
Yeah, same format.
Bateu azia? Novo leite de magnésia Eno.
Hey everybody, welcome back. Today we're going to use the map method to extract data from an array. So far we have learned to use pure functions to avoid side effects in
Title. Using parameter destructuring, the title and rating are extracted and returned in an object. Parentheses are needed to return an object.
a program. Also, we've seen the value in having a function only depend on its input arguments. This is only the beginning. As its name suggests, functional programming is centered around a theory of functions. It would make sense to be able to pass them as arguments to other functions and return a function from another function. Functions are considered first-class objects in JavaScript, which means they can be used like any other objects. They can be saved in variables, stored in an object, or passed as function arguments. Let's start with some simple array functions, which are methods on the array object prototype. In this exercise, we are looking at array.prototype.map. Or simply map. The map method iterates over each item in an array and returns a new array containing the result of calling the callback function on each watch list. So watch lists here, and then we've got a list of a bunch of movies: Dark Knight, Interstellar, and the ratings. So the ratings is an array that's being set here, and then we're saying for each element in watch list, we're adding. This was actually pass right now, but this would fail because we have a for loop right here. Your code should use the map method. We're not using the map. And then ratings should equal inception rating 8.8. So if we run the test right now, the first and the last will actually pass, but the middle won't. So what we're really just doing now is we're refactoring. Okay, so the first thing that we're going to want to do is get rid of this for statement. We don't need that.
Back a little bit.
Is test right now. The first and the last will actually pass, but the middle won't. So what we're really just doing now is we're refactoring. Okay, so the first thing that we're going to want to do is get rid of this for statement. We don't need that. We don't actually need ratings to be declared here. Let's just declare ratings specifically here. So we're going to say let ratings equal, and then we want to run a map over a map, which is a function which runs on arrays. And so we're going to map, which means we're going to take this array, and then we're going to look at each object within the array individually. And that's how map works. Map runs through each element of the array. So we're going to say watch list dot map, and then we're going to make each individual movie. So we can say movie and then we're going to pass in an object. And within this object, we'll be able to watch list, W-A-T-C-H, watch list. So now we're returning null, 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 null. But what we need to do, with each movie, we want to add a new object to the array. So let's create a new object. So let's call it let filtered array, or a refined movie data. And we're going to set this equal to an empty object. So now, if we return the refined movie object, the refined movie data, then we're passing in an object, an empty object, right? But before we return it, so 1, 2, 3, 4, 5, we've got 5 empty arrays, and that corresponds because it's going through its 1, 2, 3, 4, 5 movie objects, right? But right now we're just passing in an empty object. So what we want to do is adjust that. So we want to say refined movie data, and let's see, we want there to be a title here. So we're going to say title, and we want the title to be equal to the movie dot title with a capital T. I don't think we can do it that way. No, you can't.
That should be in brackets.
Oh, you can. Cool. So we can use either dot notation or bracket notation. You see, we get the same results. Now we've got the title in there, but then we also need the rating, right? So we're gonna do the same thing. We're gonna say refined movie data, and we wanted that to be coming out as a rating. So rating. We're gonna set this equal to movie, and here we want to get the IMDb rating. There's another rating in here, which is confusing. Oh yeah, you could do rated, but we don't want that. We want this IMDb rating, I think. So we're gonna add that in here. IMDb rating. Okay, so now we're passing in, and I think if we run the test, this will pass. Okay, cool. So let me just go over again what's happening. When we call map, the map function, well, they say up here, iterates over each item in an array and returns a new array containing the results of calling the callback function on each element. So the callback function becomes this one. This is the ES6, or so it's hidden. Another way you could write this, I'm pretty sure, you could go function movie. And then here you would need to say movie. Yeah, and so this is another way to write it. We were just writing an ES6 with that arrow function, right? So basically this is just a callback function, meaning we're going to do this function to everything in this array. And so we create, with each instance, we create a new refined movie data object, and then we assign the title to that one. And with each movie we've got, on our first element, we're doing it to, this object becomes what we're saying is movie. So this object here.
I understand now how it works, but still
becomes movie. So we come down here, we set. Now, one thing that I screwed up with when I was
it's lagging. Implement map on a prototype. As I've seen from applying map or simply map earlier, the map method returns an array of the same length as the one it was called on. It also doesn't alter the original arrays, as long as it calls back function then. In other words, map is a pure function, and its output depends solely on its input. Plus it takes another function as its argument. So I'm gonna be changing here. So this function callback. This is a map function. Var new array. Turn new array. Don't know, I guess because I want to do something real fast. S.myMap function item turn item. Okay. You might learn a lot about the map method if you implement your own version of it. It is recommended you use a for loop or array prototype for each. It's a pure function and its output solely on its input. Plus it takes another function as its arguments. You might learn a lot about the map method if you implement your own version of it. It is recommended you use a for loop or write your own array.prototype.mymap, which should be exactly like array and prototype.map. You should not use the built-in map method. The array instance can be accessed in the mymap method using this. The array instance can be accessed in the myMap method using this. Yeah, I'm confused about this one. It's gonna take the item and multiply. It's gonna multiply each value of s by 2. Cannot map on a prototype. Yeah.
Was working on this initially was I set this as title initially, and that will fail the test. So that's something you want to watch out to see. If you're not getting it right, it might be because you've got 2 capital titles. So you want a lowercase title here because you're just setting it. This could be anything, right? You're just setting whatever you want to this new key, and then this actually needs to be perfect. This actually needs to be associated with that. So like I said, the movie object is becoming this initial object here. No, it's not all of that, just to here. So movie in our instance on the first element becomes this. And so if we say movie and then with the key title, that's going to say the movie and the title, and that's why it renders inception. And so title and inception become the same, became a first key value pair of which assigned to this object. And then we do the same thing, again, lowercase rating, and then we've got to make sure to do the IMDb rating with this next one. And I'm pretty sure, yeah, you can just do this. Yeah, if you wanted to use dot notation, you can do this as well. And this works, as far as I know, exactly the same way as bracket notation. And so, yeah, if we run the test, I think they'll still pass. And so that's what happens. And then, so once we created this new object, if we were to console log the object here.
So I shouldn't use map, but I don't understand how to do this. As you have seen from applying array map, where the map method returns an array of the same length, so on. It's called on. Also doesn't alter the original array, as long as its callback function does it. In other words, map is a pure function, and its output depends solely on its input. Plus it takes another function as its argument. So is this dot new array? No. This dot push new array, push this. But this is gonna push at the values. I don't think that's right. Push is gonna change this function. How do I apply a function to the array? In other words, map is a pure function and its output depends solely on its input. Plus it takes another function that's arrow. Might learn a lot about the map method if you implement your own version of it. It is recommended use of for loop or array prototype for each. Also, I do need to use a for loop. Let me remember this for each. Okay. S dot for each. Push to another function. I don't want to push in that's the thing. That's for each. It's not. Maybe it's the element here. Maybe we should do this with lower case. Sure. Yeah. So this pushes each element of S into new array. Then returns new array. But I need to implement a function, a callback function on the maybe it's here. That's how I implement a function. It should behave exactly like a map. You should not use the built-in map. The array instance can be accessed in the myMap method using this. The array instance can be accessed in the myMap using this. This part is the one that I'm confused about. Maybe here's callback. No, but that doesn't make sense. Because I don't want to push com. And this is not gonna pass, for sure. Maybe just call back. I don't understand where this is supposed to go here. If it's telling me to use it in the array instance, it can be accessed in the MyMap method using this. Maybe I need to put new array equals to this. And here goes something like this. Let's try this out. Functions. This keyword behaves a little different in JavaScript compared to other languages. It also has some difference between strict mode and no strict mode.
Hi, I'm Olivia Wilde, actress, producer, director, mom, and today,
So what is for each? JavaScript method, duh. Yeah, but what is it really? How does it work? And what is it used for? The for each method calls a callback function once for each element in an array in ascending order. The callback function is invoked with 3 arguments: the value of the element, the index of the element, and the array object being traversed. Or in layman terms, we get an array with values and indexes and apply stuff one by one to each item. Here, we can see an example of for each working on an array I have chosen to call item array. Using this code, I'm also picking out each item of that array so I can apply logic to it. You can see here I have chosen to call it item, but I can call it whatever I want really, it doesn't matter. JavaScript will know it's an item in my array. Now, using an arrow function, I add 2 to each item of my array. Okay, so that's the syntax. Let's see it in action. Let's make an array and call it names. So an array with strings, as indicated by these 2 quote marks here, and separated by commas, put in square brackets. That is now my names array. Now, it's super important to remember what is inbuilt and what isn't here. Names isn't. Names is our array that we have made above. For each is the inbuilt method that comes with some magic that will make our JavaScript do things without us writing any logic for it. So that is inbuilt. Name here is something that we have chosen to call each item in our array. I could call this, I don't know, chair or whatever. My JavaScript will still know I mean an item in my names array. This arrow is an arrow function. If you don't know much about arrow functions, please watch my arrow function video after this. So what we are saying here is that for each item or name in our names array, I want to print out individually and add the string is the best to each item. Let's check that out. Okay, and that has worked. Great. Now, this is a super simple example of how to use for each with an array. There are literally so many different ways in which you can use this inbuilt method. Shall we do a JavaScript games related one? Yeah. Okay, so in this example, it's going to be a little bit more difficult as we're going to be using 2 other inbuilt methods, but what the hey, let's do it anyway. Okay, now you might have seen me do this before in the memory game or whack-a-mole. We are going to add an event listener to each square in our grid. The first thing we do is get all our squares from our grid. We do so using query selector all for our HTML document. So it finds all the div elements and assigns them to the const squares. Now, again, using the same logic for each item, or as we have chosen to call it, square of our squares, so all 9 of them, we want to add an inbuilt method called event listener and pass through a click and a function we have called click outcomes. This means that if we click the element, we invoke the click outcome function. What is this function? Well, we need to write it. Let's do that here and make this function send off an alert. Okay, great. Now let's test that out. And perfect. Hopefully that sheds some light on the for each inbuilt method. If you want to see my videos on the arrow function, event listener, and query selector, please watch my other videos below. Thanks for watching, and please do subscribe to my channel. I'm going to be going through all of JavaScript's inbuilt methods in 5-minute videos.
The array instance can be accessed in the my method using this. Why is it giving me undefined? Is it exactly the way I wrote it? Maybe there's no need for this. Yeah, there we go. Okay. And now, what do I do? I need to use this callback function somehow. Maybe callback new array. It still doesn't change anything. This function callback needs to be applied in new array. The array instance can be accessed in the main method using this. I don't understand what this means. Yeah. I remember this, but to access things, but I don't know in this context what the exercise is referring to. Maybe yeah. And this is not working as well. So this callback is going to be item here, or it's going to be the whole function. Yeah, I don't understand. I think I'm gonna have to look for the hint and the answer from the guy. I don't understand what the exercise wants me to do. I guess it wants me to apply this function on S without changing S. But I don't understand how this callback is related to. How do I apply the callback to new array? Maybe if I want to do like this. It doesn't work as well. New array. Yeah, let's look at the hints. I don't remember very well all those things about this and the objects and how they are related and all the other lessons that I learned. Okay, so this is right. Well, it's exactly what I did. Oh, it uses this here instead of new array. That was what is wrong. But it's still giving me the wrong number here. What's the difference? Push callback. Push callback A. Now it's right. But I don't understand. This keyword gives us access to the object we are calling my map on. Yeah, maybe I have to look to review this. And there we can use the for each method to add elements already declared empty array as we modify each element with the given callback method. This is the for loop, the same thing. Let's see how the guys solved. I think this is one.
Ter Oi Fibra é aproveitar 200 MB por R$ 99,90. Ficar todo mundo conectado.
Hello friends, welcome back. Today we're going Hello friends, welcome back. Today we're going to implement map on a prototype. As you've seen from applying array.prototype.map or simply map earlier, the map method returns an array of the same length as the one it was called on. It also doesn't alter the original array as long as its callback function doesn't. In other words, map is a pure function and its output depends solely on its inputs. Plus, it takes another function as its argument. It would teach us a lot about map to try to implement a version of it that behaves exactly like array.prototype.map with a for loop or array.prototype.forEach.
This guy reminds me of the Chester from Linkin Park.
Pure function is allowed to alter local variables defined within its scope, although it's preferable to avoid that as well. Write your array.prototype.mymap, which should behave exactly like prototype.map, and you may use a for loop or a for each. Cool. So I think I'm going to do a for loop because I think that's more specific, and I'll do a for each afterwards. First off, we're going to create a for loop. So we're going to let I equal 0. I is less than. Okay, so this is the kind of maybe a tricky part. We're calling this function on an array. And so how do you do that? You get the prototype comes, when we call this function, what we're doing is calling it on the thing that we're passing it on. So s.this. So because s is an array, it's going to have array prototype functions associated with it. Here, we're setting my map as a prototype of array. We're adding this to the array options. So s.mymap. And so what we can do is say this.
Oh, yeah.
And we'll call it this.length, right? So in this example here, because s is assigned up here, for the first element, we're saying this. So this element dot length, the length, so 0, 1, or 1, 2, 3, 4. So I is less than 4. And then we want to increment I. And then with each one, what we want to do is add to the new array. So the new array dot push, so we're adding on to the new array.
Yeah,
what do we want to write? We want to add on
it can be any array.
Whatever the callback function is, right? So we're passing a callback into here. So when someone calls my map, they're going to be calling it on an array. And then in there, we're going to get this function. We don't know what this function is now, so we just want to be able to dynamically assign it, right? So we're saying callback. And we're calling it on this, but it's this. If we just put this in here, that would be the whole array. So we need it to be this at position I. So each time it's going to be passing in the individual pieces of this. So your new array comes in, and then for each element, we're calling the callback function on each individual bit, and then we're adding that to the new array. If we were to console log this, this at position I, you're going to see we're going to go 23, 65, 90, 98, and 5, and we're passing those in. And so once we're done with that loop, if we were to console log the new array, you're going to see that it loops through and it adds each of these. Is it already doing it? 20, 46. Oh yeah, it's actually already logging those through. But if we were to just, instead of making this times 2, it did that. We would still just pass through. So we're just assigning it to the new one. So yeah, here we've got, well, this is the response. We want 46, 130, 196, 10. So I'm pretty confident that this would pass the test because we're passing in the new array, and your code should not use map. So this will probably pass the test. Once we console log the new array, or instead of doing that up here where we're in our function. Obviously, we don't really want to console log the new array. We would want to console.log the new s here. And let's get rid of the console log in here. Now we know that we're iterating through each element. Oh, and do you notice how each element that we iterate through is, it's 23, 65, and 98, and 5 here, but then once it's assigned to the new array, it's 46, 130. Why is that? Because we passed the callback function with each individual element there. Yeah, we could say like, we could say let array individual. We could refactor this and say this at position I, and then we pass the individual element into the callback function. This gives us the right answer as well, but it actually almost makes it more readable, right? If you're reading this code, you can say we're creating an individual element at position I, so we know that that's each individual element, and we're pushing onto the new array the result of passing the individual element into the callback function, and then we return the new array. And now if we console log, so here we pass in this original array, and we do.
Another use for array function is array prototype filter, or simply filter. A filter calls a function on each element of an array and returns the new array containing only the elements for which that function returns true. In other words, if it filters the array based on the function best fit, like map, it does this without needing to modify the original array. Callback function accepts the 3 arguments. First argument is the current element being processed, the second is the index, the third is the array upon which the filter method was called. So now it's gonna ask me to filter watch list. Not filter. Maybe it's the other way around. No, it's correct. See below for an example using the filter method on the user's array to return a new array containing only the users under the age of 30. For simplicity, the example only uses the first argument of the callback. But why make it simple in the example? I want to see one that's complex, so I can understand where the other parts of the method go. See below, for example, using the filter method on the user's array to return a new array containing only the users under the age of 30. So it's filtering. The variable watch list holds an array of objects with information on several movies. Use a combination of filter and map on watch list to assign a new array of objects with only title and rating keys. New array should only include objects where IMDb rating is greater than or equal to 8. Note that the rating values are saved as strings in the object, and you may need to convert them into numbers to perform mathematical operations on them. God damn. So this is a big one. Well, first I need to use map to find title and ratings. Use a combination of filter and map on watch list. New array of objects with only title and ratings. So the map one is gonna be I don't remember. I think it's title. Why it says this is wrong? Title is not defined. His watch list. Not title. He's telling me undefined is not a function. Maybe it's because of this one. I'm gonna erase this. Actually, let's go with no. Let's go with the dots. So this is gonna select into this new array the watch list title and IMDb rating. Then I need to convert the IMDb rating from a string to a number. And then do the filter. So how do I do that? But it's not to really convert the string into a number. It's to make the string on a string. This parse float function, which purchases a string and returns a floating point number. So UR.filter. The new array should only include objects where IMDb rating is greater than or equal to Okay, so this is clearly wrong because it has to be a dot. And this is not floating the or turning into a string. Yeah. Why is giving me undefined? That's not what I want. No, it's still not working.
Dear builders, we know that right now,
Hello! In this series, we are learning how to do functional programming in JavaScript. You can find the full series by clicking there. In the last episode, we learned about higher order functions. Since functions are just values, like any other value in JavaScript, we can exploit that by making functions that take other functions as their arguments. And that is called a higher order function. We also learned to use a higher order function, filter. We learned that filter is a method on the array object that takes another function as its argument and uses that function to filter the array. In this episode, we're gonna learn about something new and awesome called map. Just like filter, map is another higher order function. Also,
Why is not pushing the values? New array dot push. Don't watch this.
So like filter, it goes through an array, but unlike filter, it doesn't throw the objects away. Instead, it transforms them. What?
What does it mean?
Let me show you. Take a look at this array. You might notice that I'm reusing the array from the previous video, but that is simply because arrays of animals is very, very common in enterprise-grade programming. But the problem is different this time around. We want to get an array of all the names of all the animals. This is super simple to solve with map, but before I do, I want to show you how we would solve this using a for loop. So let's check out what this does. Just console log output, run it. And you see that this just logs out the names. The code is super straightforward. It just loops the animals array, and for each animal, it just picks the name property and it pushes it into the names array that we create on line 10. Now, let's do the exact same thing, but using map instead. I'll comment out the for loop here and keep it around for comparison purposes. Right, let's do this. Remember that I told you that map is a function on the array object, just like filter is. Map will take a callback function, just like filter does. The callback function will be passed each item in the animals array. But here is where map gets different from filter. Filter expects that its callback function to return a true or false value that determines whether or not the item should be included in the array or not. Map will include all items in the array, but instead it expects the callback function to return a transformed object that it will put into the new array instead of the original animal. In this case, that will be the name. Like that. Now, let's save and run it and see if it produces the same output as the for loop. Bam! Exactly the same. Using map to return a subset of an object like this, where we return just the name property, is a very common usage pattern. However, since map just expects the callback to return any object, we can use it to create completely new objects. Let's run that. Ta-da! Fluffykins is a rabbit, Coro is a dog, Hamilton is a... Yeah, they're getting it, don't. But do you see how little code this is? It is amazing! I'm gonna put the for loop example next to the map example so that you can compare, and I'm gonna remove the extra code that we added to the map so that they are doing the same thing. Now, check here when I'm selecting the map example, and here in the lower left corner you see that it's 66 characters, and when I select the for loop example, you see that it's 89 characters. That's like 30% more. Let me put it like in one line just to show you the size difference. I'm gonna pull this out a bit. That is a lot shorter. Short code is good, because less code almost always means less bugs, but it gets even better. In ECMAScript 6, we're getting arrow functions. I'm gonna rewrite this using arrow functions. Arrow functions is a new, shorter, and better syntax for functions in ECMAScript 6. It looks like this. So, it's a bit shorter, but it gets better. If your function logic fits on one line, like in this example, you can just get rid of the return statement and the curly brackets, and this will, whatever statement is after the arrow function, will be implicitly returned. So let me comment out the stuff that we keep around for comparison, and go back to the console, and run this. Whoops, this won't work right off the bat, because as I said, arrow functions are a part of the ECMAScript 6 standard, and that is not fully implemented into browsers or Node yet. However, if you're running the latest version of IO.js, you can just use the Harmony arrow functions flag. And it works. If you're watching this video from the future, you don't have to do this. In functional programming, it's common to go even shorter and just shorten the variable names to x, like this.
Another very useful and powerful method we have in modern JavaScript is the map method. With this method, we can map each item in an array to something else. So following from the example in the last lecture, we have an array of positive numbers. Let's say we want to construct some HTML markup using the elements in this array. So we call filtered.map. And once again, we need to pass a callback function here. This function, just like the function that we passed to the filter method, can have 3 parameters: value, index, and array. So in this case, again, we're going to work only with the value. So we can pass a function or an arrow function. So we get a number, and then we're going to map this to some HTML markup. So we can add a string in an opening list item element, then we add the number, and finally the closing list item element. So with this markup, we can display each number using a bullet point.
Why does this doesn't work? Pushing the index. Rise to 1, 2, 3, 4, 5.
Of course, we need to put these inside of a UL element. I'm going to show you that in a second. So let's see the result of the map method. I'm going to store the result in a constant called items. And now let's display this on the console. So you can see each number is now mapped to a string. That's a list item. So now
Welcome back, baby, or welcome for the first time, who knows. This video now, I am going to talk about these higher order functions. This is really just kind of me like trying to sound smart, make it sound fancy. These are just functions that I can call on arrays in JavaScript. So you might really think of an array as like, oh, array, it's a list of stuff. It's an ordered list of things. Like it might be an ordered list of numbers, like this. And I can iterate with a for loop. I can, use, I could, that kind of thing. I could iterate with a for loop. Like how would I calculate the sum of everything in this array? I would have a for loop, and I'd start with the variable sum equals 0, and then I add the first element, and the second element, and the third element. So what I'm saying is that these higher order functions, these array functions, allow you to manipulate the array as a whole, all in one fell swoop. And you actually have seen this before if you watch any of my videos. For example, push. This is not a higher order function because it doesn't receive a function as an argument, but it does manipulate the array. So if I say push and I pass in 7, then it will add an extra element to the end of the array. Now, what's actually doing behind the scenes with all that? That's a topic of discussion for another time. What I want to look at is, let's look at these first. So where do these come from, and what do they do? So over here, this is the Mozilla Foundation web docs. There are lots of places to find resources about what the various things available in the browser in JavaScript are. But this is the JavaScript array object. And so the array object, this is how you might think of it usually. It's got two things, like a string, and you console log the length, and you get 2. But if I go over here to the left, I'm going to see, oh, look, all these other functions. For example, and they're listed here as array.prototype.push. Now, I do have a video about what the prototype thing is. Luckily, what I'm doing now is I'm living in this world of JavaScript ES6, the version of JavaScript 6. And you don't really have to mess with the prototype too much. That's another topic for another time. But this is where I can find the list of the functions. So if I click on push, I would find like, oh, look, this is what it does. If I say animals.push cows, now it switches at the end. So this is a little bit sillier here. And and then console.log vals. Now, I'm going to leave all this here. So let's look at what's going on here. I have the array. I'm going to look at it. Then I'm going to define a function called doubler. Then I'm going to pass doubler via the map function to vals. So I should see the array have 8, 16, 2, 4, 18. Now, it's not going to do that because I made a little mistake here, but let's take a look. So now I'm going to come up here, save, I'm going to come up here, hit refresh.
Let me go back to the video of this guy.
Precisa aceitar cartão de crédito e boleto na sua loja online? Cadastre-se no Pagar-me.
Bateu azia? Novo leite de magnésia Eno.
Hey everybody, welcome back. Today we're going to use the map method to extract data from an array. So far we have learned to use pure functions to avoid side effects in a program. Also, we have seen the value in having a function only depend on its input arguments. This is only the beginning. As its name suggests, functional programming is centered around a theory of functions. It would make sense. And so we say user.name, so it comes in, it says we... Cool, so...
Grab some water, be right back.
The watch list array holds objects with information on several movies. Use map on the watch list. So watch list is here, and then we've got a list of a bunch of movies: Dark Knight, Interstellar, Inception. We've got this giant list. To assign a new array of objects with only the title and rating keys to the ratings variable. So here we want to add our code below, and we want to add your code above this line. So we're going to alter this code. And right now we're console logging, and we're returning the ratings. So the ratings is an array that's being set here. And then we're saying for each element in watch list, we're adding the watch list at position I title and the rating. Okay, so we're actually getting the result that we want already. This is, they're doing it, but they're not using the map function. So we want the watch list variable should not change. So we're not supposed to mutate the original variable. Your code should not use a for loop. So yeah, this was actually passed right now, but this would fail because we have a for loop right here. Your code should use the map method. We're not using the map. And then ratings should equal Inception rating 8.8. So if we run the tests right now, the first and the last will actually pass, but the middle won't. So what we're really just doing now is we're refactoring. Okay, so the first thing that we're going to want to do is get rid of this for statement. We don't need that. We don't actually need ratings to be declared here. Let's just declare ratings specifically here. So we're going to say let ratings equal, and then we want to run a map over a map, which is a function which runs on arrays. And so we're going to map, which means we're going to take this array, and then we're going to look at each object within the array individually. And that's how map works. Map runs through each element of the array. So we're going to say watch list dot map, and then we're going to make each individual movie. So we can say movie. And then we're going to pass in an object. And within this object, we'll be able to watch list, WATCH, watch list. So now we're returning null, 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 null. But what we need to do, with each movie, we want to add a new object to the array. So let's create a new object. So let's call it let filtered array, or a refined movie data. And we're going to set this equal to an empty object. And so now if we return the refined movie object, the refined movie data, then we're passing in an object, an empty object, right? But before we return it, so 1, 2, 3, 4, 5, we've got 5 empty arrays, and that corresponds because it's going through its 1, 2, 3, 4, 5 movie objects, right? But right now we're just passing in an empty object. So what we want to do is adjust that. So we want to say refined movie data, and let's see, we want there to be a title here. So we're going to say title, and we want the title to be equal to the movie dot title with a capital T. I don't think we can do it that way. No, you can't. Oh, you can. Cool. So we can use either dot notation or bracket notation. You see, we get the same results. Now we've got the title in there, but then we also need the rating, right? So we're going to do
the movie's not fine. Oh, let's watch that movie. I'm still turning 1, 2, 3, 4, 5.
do the same thing. We're going to say refined movie data, and we want that to be coming out as a rating. So rating, we're going to set this equal to movie, and here we want to get the IMDb rating. There's another rating in here which is confusing. Oh yeah, you could do rated, but we don't want that. We want this IMDb rating, I think. So we're going to add that in here. IMDb rating. Okay, so now we're passing in. And I think if we run the test, this will pass. Okay, cool. So let me just go over again what's happening. When we call map, the map function, well, they say up here, iterates over each item in an array and returns a new array containing the results of calling the callback function on each element. So the callback function becomes this one. This is ES6, or so it's hidden. Another way you could write this, I'm pretty sure you could go function movie and then here you would need to say movie. Yeah, and so this is another way to write it, where you're just writing an ES6 with that arrow function, right? So basically this is just a callback function, meaning we're going to do this function to everything in this array. And so we create, with each instance, we create a new refined movie data object, and then we assign the title to that one. And with each movie, we've got, on our first element, we're doing it to this object becomes what we're saying is movie. So this object here becomes movie. So we come down here, we set. Now, one thing that I screwed up with when I was working on this initially was I set this as title initially, and that will fail the test. So that's something you want to watch out to see. If you're not getting it right, it might be because you've got 2 capital titles. So you want a lowercase title here because you're just setting it. This could be anything, right? You're just setting whatever you want to this new key, and then this actually needs to be perfect. This actually needs to be associated with that. So like I said, the movie object is becoming this initial object here. No, it's not all of that, just to here. So movie in our instance on the first element becomes this. And so if we say movie and then with the key title, that's going to say the movie and the title, and that's why it renders inception. And so title and inception became a first key value pair of which assigned to this object. And then we do the same thing, again, lowercase rating, and then we've got to make sure to do the IMDb.
Why is this wrong?
Rating, right?
Assign new array of objects with only title and rating keys. The new array should only include objects where MDB rating is greater than or equal to 8. Just this. Why is not filtering? Yeah, I don't know. I think after this, well, I'm gonna be done for today. It does it the other way around. But how does it know it's a number? Return. Forgot the brackets here. I think I'll look through this another day. I'm gonna watch the guy's video and then next time I'm on, I'm gonna try to solve it again.
Hello friends, welcome back. Today we're going to use the filter method to extract data from an array. Another useful array function is array.prototype.filter, or simply filter. Filter calls a function on each element of an array and returns a new array containing only the elements of which that function returns true. In other words, it filters the array based on the function passed to it. Like map, it does this without needing to modify the original array. The callback function accepts 3 arguments. The first argument is the current element being processed. We use ES, it saves the entire. The variable watch objects with only title and rating keys. The new array should only include objects where IMDb rating is greater than or equal to 8. Note that the rating values are saved as strings in the object, and you may need to convert them into numbers to perform math. To my watch list, is that right? Watch list. We'll make it equal to watch list dot map, and then I'm going to do this first off just in old school JavaScript, and then we'll move on to doing it. I'll show you, I'll refactor it later into ES6. So yeah, watchlist.map. And then, so with here, we're going to say each individual movie. Each individual movie. Now I use long variable names because I think long variable names make code easier to understand what's going on. So first off, we want to return, well, what do we want to return? With each, we're going to map through this first. So what we want to do, this is the exact same thing that we did in the last lesson. We're going to create a refined, we need to say let refined data equal an object. Refined movie data. I think that's more explicit. So refined movie data. And then we want it to be the title with a lowercase t is equal to the individual movie dot title. And why do I use a capital T? Because the title here is assigned to capital T, because I'm saying each individual movie and then dot title. So we're pulling the individual parts out of here. I use bracket notation here. I should use dot notation across all of this to be consistent. It makes your code more readable. And then we return the individual or the refined movie data. And so now we're returning a title, but obviously, well, here we have the title, but we don't have the rating. We want to return a title and the rating. So we'll go refined movie data dot rating is equal to individual movie dot IMDb rating. So this guy, individual movie. Cool. So now we're passing this all in. But what we're trying to do is filter out any movies that don't have a rating above 8. So we actually don't want this avatar in there. This is what's causing our error. This would cause us to not pass this test because avatar is not in here. Just Batman Begins would be. And so how do we filter out that? Well, we can come here. We've completed our map function, and that's passing. That's cleaning up our data. And then we can say dot filter. And then let's use, as like I said, we'll refactor later. We'll use this original JavaScript. And then I'm going to say individual movie again. And then what we want to say is if the individual movie.
Let me try something, see if it works. Just for fun. Yeah, it doesn't work. I wonder why though. Anyway.
Individual movie dot rating. Okay, let's say individual movie rating. Let's say let individual movie rating, but we want to set this equal to so rating integer, because what right now the individual movie rating is being passed in. If we were to console log this rating integer, what we're doing is we're getting each of these, but the integer, but it's not an integer. If we were to go to the type of, we're getting a string. Now you can't add strings. You can't make conditional statements from them. So what we need to do is convert this string into an integer, right? So we're going to say parse int. Now this passes in, but this doesn't work necessarily because we want it to be less than or equal to 8. So, well, this would work, but I think it makes more sense to say parse float. But this does work. If we were to go type of now, we're going to see these are numbers, so we could do mathematical conditional statements on them. But let's make it parse float, and that way we get the floating integers, which I think is more useful. And so now, oh, we should do this up here on the actual rating integer. So now our rating integer, if we go type of, we should get number. And so now we can do conditional statements on it. So our rating integer. So I'm just going to take this and put it in here. Command and the question mark / / key to uncomment. So if rating integer is greater than or equal to 8.0, then we can return. Then we return, what do we return? Not the rating integer, but we want to return the individual movie. And we can get rid of this console log now. And so now we've got an array, and it doesn't have that last element in it because it's not returning that. So I think if we run the test, that should pass. Okay, cool. So I hope that this makes sense. I tried to go through it as slowly and as focused as possible. Let's say we wanted to use ES6 instead of this older school JavaScript. We get rid of this function and we can call individual movie like this. This will still work. So same thing here. We can do the ES6 and use arrow functions to clean the code up a little bit. Let's see, we could do a single line if statement here. How do you do that? Single line JavaScript. Single line if statements. If lemons. Okay, so I think we could go if rating integer return individual movie. Cool. That would actually get us a little bit more succinct code. We could do this instead of saying individual rating integer. That gets us even less lines of code, though I think this becomes more difficult to read. I personally would rather do it like this. I would rather leave it here because I like being able to read my code. And so, yeah. Anyways, I think this passes the test, and that gives you an idea for how it works. Hope you guys enjoyed this one, and we'll see you.
Alright, I'm done for today. Maybe I'll come back tomorrow, maybe Thursday. So, see you.